Today, we have a very nice exponential equation to solve. We need to find the exact value of x when x raised to the power of x is equal to 25. Your first thought might be that 25 can be cleanly written as 5 squared. But if you look closely, our equation is x to the power of x, which doesn't quite match the format of 5 squared. So the answer is going to be a bit more complicated than that. Let's estimate where our answer should actually fall. We know that 2 raised to the power of 2 is 4, and 3 raised to the power of 3 is 27. So we can be absolutely sure that the value of x lies somewhere between 2 and 3. And because x to the power of x is a strictly increasing curve, there is only one real number solution to this problem. Now, let's find it using algebra. First, let's apply the natural log to both sides. This gives us the natural log of x to the power of x equals the natural log of 25. Using the power rule of logarithms, we can pull that exponent right down to the front. We can rewrite the left side as x times the natural log of x. Our equation is now x times the natural log of x equals the natural log of 25. To solve this further, we are going to use a brilliant mathematical tool called the Lambert W function. Here is how it works. Suppose we have an expression in the form of a times e to the power of a. When we apply the Lambert W function to this exact expression, it collapses beautifully and simply returns the value a. That is the magic of the Lambert W function. But if you look at our equation, we don't have an e. So we have to introduce it ourselves. We can legally rewrite x as e raised to the power of the natural log of x. Let's substitute that back into our equation. Now we have e raised to the natural log of x times the natural log of x equals the natural log of 25. Since this is just simple multiplication, let's flip the order on the left side to perfectly match our Lambert W format. It becomes the natural log of x times e raised to the natural log of x equals the natural log of 25. Look at that! It perfectly matches the form. A times e to the power of a. In our case, the value of a is exactly the natural log of x. Now we are ready to apply the Lambert W function to both sides. On the left side, the Lambert W function does its magic and leaves us with just our a value, which is the natural log of x. On the right side, we simply have the Lambert W function of the natural log of 25. Don't be intimidated by that right side. The natural log of 25 is just a constant number, which means that entire expression is just a constant as well. We are almost there. We have the natural log of x, but we want x by itself. To undo the natural log, we will use e as the base on both sides. This gives us e raised to the natural log of x equals e raised to the Lambert W function of the natural log of 25. On the left, e and the natural log cancel each other out, leaving us with exactly x. So, our exact final answer is x equals e raised to the Lambert W function of the natural log of 25. If you plug this constant into a calculator to see the actual decimal value, you will get approximately 2.963. This perfectly matches our earlier estimate that the answer would fall right between 2 and 3. And that is how you dismantle an intimidating exponential equation. If you enjoyed this logical breakdown, please hit that subscribe button, and I'll see you guys in the next one.